I'd like to go into a little more detail about how Matlab passes arguments in function calls. Here's a function that has 2 input arguments and 3 output arguments with some unspecified code that we could fill in. Pictorially, there are 2 input arguments, 1 and 2, and they get mapped through the function to produce 3 output arguments. The questions addressed by the next few slides are: how are variables passed into the function, and how are variables passed back to the caller? Before addressing those questions, let's take on an even simpler one. How does Matlab copy variables? We'll look at the easiest case where we copy a variable such as a double. Create a variable A, in this case size 2 by 3. Some component of Matlab is managing the objects as they're created. Now this data needs to be stored in memory, so let's look a little bit at the memory as well. Memory consists of an address where the memory is stored and then the contents at that location. Addresses are usually written in this hexadecimal format. We'll actually study that in a few modules. For now, just think of it as a base 16 number. So there's the numbers 0 through 9, as well as the letters A through F to represent the numbers 10 through 15. The X stands for hexadecimal. The correct interpretation of hexadecimal is not important here. Just I'm going to use that to indicate addresses. And then the contents are listed on the right. So here it says at memory location 2F44 in hexadecimal, there is a number stored there. The number is 7.99451. The data in array A is stored somewhere. The object manager also keeps track of that. Where is the data in A stored? In this instance, A is stored at location 2F45. There's 6 elements of A, and they're stored contiguously using linear ordering, as we learned about earlier. So 1 is the first element, 4 is the second, 2, 5, 3, and 6. Now consider the operation of copying A into a new variable B. So a new variable gets created, and the object manager is tracking that. B is size 2 by 3. What's surprising is that the data address is exactly the same place. At this point, A and B in the object manager refer to exactly the same 6 locations in memory. But we have experience with Matlab, and we know that's not how it behaves. If we change the to entry of A, the to entry of B does not change. Even though we're very familiar with this, let's check it out in Matlab just to be sure. Create the array A. Copy A into a new variable B. Change the to entry of A to a new value. And confirm that B has not changed. Therefore, it must be something in the slides is incomplete. Let's go back and finish the story. I claimed that when we copied A into B, the variables maintained by the object manager actually point to the same 6 locations in memory. Then, changing the to entry of A would change the to entry of B, which we saw is absolutely not the case. A and B are individual entities. What really occurs is that when an element of one of these arrays is changed, some other things have to happen. The contents of A is copied to a separate place, and then there the change is made, and finally the object manager reassigns the data address to the new correct address. Now the data for A and B occupy different locations in memory. They are separate, as we perceived all along. This is called delayed copy. When a copy operation is initiated, no actual copy takes place. However, anytime one of the variables is changed, this forces the real copying, and some work had to be done, as we illustrated here, when this data was copied down to this data. So what does this delayed copy mechanism have to do with argument passing in function calls? Well, it turns out that's exactly how argument passing in function calls is performed. Let's visualize an abstraction of this process. There's the object manager. and the workspace manager, whose purpose will become clear as we progress through the example. What we'll see is that argument passing is always done by delayed copy. Create a variable A. The Matlab command window prompt is shown here, so this is happening in the base workspace. Notice that the object manager is not only keeping track of the variable name, size, and starting address for its data, but it also is logging which workspace the variable belongs to. Create a variable B, also in the base workspace. Now, let's call a function. First, a function instance workspace is created. I'm labeling it as though the name of the workspace is the function name with an _1 as it's the first instance. The caller of this workspace is the base workspace, as that's where the function call initiated from. The input arguments A and B are passed by delayed copy. The object manager is now managing two more variables, X and Y. They belong to the vfunction _1 workspace, but notice that their data is exactly the same data address corresponding to A and B. These are delayed copies of A and B. Next, the function executes a command that creates a variable in the function instance workspace. The next line overwrites one of the entries of the X array. Here is where the delayed copy mechanism must finally make the copy. So X is altered and no longer shares the same memory as A, but is now in a new location, and the modification caused by this line of code has been carried out. Finally, another variable is created, Z, that lives in the function instance workspace. And now the function is ready to exit. Z is the output argument of the function, so it will be passed back through the function call to the argument C in the base workspace. This is also done by delayed copy. Notice that everything is the same as Z except its workspace is the base. And finally, the function exits and the function workspace disappears, as well as all the variables in that workspace, leaving variables A, B, and C in the base workspace. There are two main consequences to argument passing by delayed copy, and we should go over those in a summary. First, the function is acting on copies of the variables from the calling workspace. Therefore, the values of variables in the calling workspace are never changed by the code that executes in the function. The function is acting on copies of those variables, not the variables themselves. However, there is no cost to passing extremely large arrays into functions because the copy is really a delayed copy. No copy is made until the function actually modifies that argument. At that point, the expensive copy aspect is activated and some time and memory will be used. So to summarize, input arguments to Matlab functions are copies of the variables in the calling workspace, but the copy is a delayed copy.